Okay, we've literally all been there, right? You're trying to wrap your head around a complex new topic, and suddenly you are just drowning in like 50 open browser tabs. You're hopelessly trying to cross-reference articles, data sets, PDFs, and it ends up eating your entire weekend. It's the universal pain of information overload. But what if you could compress hours of that grueling due diligence into just a few minutes? Well, welcome to this explainer. Today we're going to completely dismantle the technical architecture of Gemini Deep Research. We are going right under the hood to see exactly how Google transformed a standard conversational AI into a tireless, autonomous research analyst. So let's dive into this by contrasting what we're all used to against what this new system actually does. Standard Gemini models operate on seconds of latency. You give them a prompt, they generate text, and output it right away. Simple. But the Gemini Deep Research agent, it's a completely different beast. The latency here is measured in minutes, not seconds. And the process is entirely different. It plans, it searches, it reads, it iterates, and only then does it output. This is a true agentic workflow. It doesn't just guess an answer, it actively hunts for it across the web.
Here is our agenda for today. 1. The research nightmare solved. 2. Enter the Interactions API. 3. Orchestrators and collaborative planning. 4. The cognitive science engine. 5. Synthesis, citations, and visuals. And 6. The analyst in a box.
Let's start with part 1, the research nightmare solved.
Moving right along to part 2, enter the Interactions API.
To make this autonomous loop possible, the engineers at Google DeepMind had to fundamentally shift their whole approach. You see, the old standard API call, generate content, was built for quick, stateless request and response text generation. Trying to force a 10-minute, multi-step research loop into that old system, it would just result in terrible timeouts. So, the solution is the completely new Interactions API. This asynchronous interface acts as the foundation for these agentic apps. Because deep research takes 5, 10 minutes, or sometimes even longer, and maintains a shared server-side state. Meaning, if you kick off a massive research project and accidentally slam your laptop shut mid-process, you don't have to panic. The system doesn't crash. It gracefully continues recovering, planning, and processing in the background, so your results are just waiting for you when you get back.
Okay, part 3, orchestrators and collaborative planning.
So how does this actually kick off? When you hit submit, you aren't just talking to a single model. You're talking to an orchestrator. It operates a lot like a general contractor that delegates tasks to various specialized subagents to do the actual heavy lifting. Now, before the agent searches for a single thing, the planner agent produces a multi-point research plan. The developers call this an editable chain of thought. You can collaboratively review this plan, tell the AI to, focus more on one specific area or completely ignore another and refine it through multi-turn interactions. Only when you approve it does the actual execution begin. It's exactly like briefing a human intern and having them repeat the plan back to you to make absolutely sure they're on the right track.
Once that plan gets the green light, the orchestrator delegates queries out to its specialized tools. It uses Google Search for the public web, URL context to read specific pages, and code execution for any heavy data analysis. But most importantly for enterprise users, it uses MCP servers, or Model Context Protocol. This is an absolute game changer. It means the agent can securely tap directly into your proprietary enterprise data, your remote servers or private APIs, seamlessly blending the open web with your private internal data streams.
Next up, part 4, the cognitive science engine.
You might be wondering, how does an AI maintain the context of a massive investigation across dozens of websites without losing its train of thought? Well, it all comes down to some truly brilliant context management. The system leverages Gemini's massive 1 to 2 million token context window for active tasks. It's holding huge amounts of browsed HTML and data right in its active memory. But when that memory limit is finally approached, it falls back to Retrieval Augmented Generation, or RAG. It's essentially storing older history in a searchable filing cabinet to pull from later. The agent acts kind of like the human brain's hippocampus, actively pulling in fragments of data and binding them all together to form a cohesive working understanding of the topic.
And hey, those biological comparisons, they are definitely not an accident. Back in 2009, Google DeepMind founder Demis Hassabis proposed something called scene construction theory in his PhD thesis. He posited that the brain proactively constructs simulated futures to evaluate what might happen next, all before taking any real action. That exact theory is now deeply embedded in how this agent is literally designed to think. To turn that biological theory into actual code, the agent utilizes Monte Carlo tree search. It builds look-ahead trees to approximate future research outcomes, simulating different paths it could potentially take. And as it browses, a specialized sufficient context agent actively evaluates the gathered data. If it spots a gap in its knowledge, it doesn't just error out and fail. It triggers an asynchronous course correction, looping back to run new, highly specific queries until its internal simulation is completely satisfied.
Which brings us to part 5, synthesis, citations, and visuals. After those continuous reasoning loops mathematically satisfy all the knowledge gaps, the web agents return their extracted snippets and URLs. Then, a synthesis agent steps in to bind everything together, resolving overlapping information and converting all that raw web data into a comprehensive report. And the outputs are strictly professional. Every single claim is backed by an inline citation tied to the exact URL it was pulled from. Even more impressive, the agent natively generates presentation-ready visual charts and infographics entirely from scratch using dynamic HTML rendering tools. It gives you a fully formatted multi-page executive summary.
Finally, part 6, the analyst in a box.
The crucial point I want you to take away from all this is that we are no longer just dealing with conversational chatbots that summarize a single article for you. We are interacting with a tireless, highly specialized research partner. This is all achieved through heavily custom-tuned models, specifically Deep Research Max. This model underwent specialized post-training to intentionally prioritize deep, extended test time reasoning over low latency. By actually taking the time to think, search, and verify, complex workloads like competitive intelligence, market analysis, and exhaustive literature reviews are permanently transformed. It literally compresses hours of manual due diligence into just minutes of high-quality insight.
As we wrap up this explainer, I want to leave you with one final provocative question. If an AI can autonomously plan, rigorously search, and scientifically reason through the world's knowledge in a matter of minutes, what impossible problem will you unleash this analyst in a box on tomorrow? The architecture is there, the API is available, and the era of autonomous research has officially arrived. Thanks so much for joining me to look under the hood of Gemini Deep Research. Catch you next time.